Imagine baking a cake in a star-shaped pan when the recipe expects a round one. The result? Burnt edges, gooey center. The shape matters. Data analysis is similar. The shape of your data, its assumptions, matters before any test. Two key shapes, linearity and normality. Check them for reliable results. Linearity means the relationship between two variables can be described with a straight line. In other words, as one variable changes, the other changes at a constant rate. This is one of the simplest and most predictable relationships in mathematics and science. For example, as temperature rises, ice cream sales go up, a classic straight line relationship. The hotter it gets, the more people crave a cold treat, and the increase in sales is steady and predictable. Or the more you study, the higher your exam score tends to be. Each extra hour you put in usually leads to a similar boost in your results, at least up to a point. If you plot study time against grades, you'll see a general upward trend. The points on the graph line up in a way that forms a straight path, showing a clear direct connection. This is what we call a linear relationship. It's simple, easy to spot, and forms the backbone of many statistical analyses. Why does this matter? Many statistical tests, like correlation and regression, are built to detect straight-line patterns. These methods assume that the relationship between your variables is linear. If your data is curvy, these tests will miss the real relationship or underestimate its strength. They simply aren't designed to handle twists and turns in your data. It's like measuring a winding road with a straight plank. You'll get the wrong answer. The tool doesn't fit the job, and your results won't reflect reality. That's why checking for linearity is step one. Before you run any tests, make sure your data actually fits the assumptions those tests require. If your data isn't linear, using a linear test is like using the wrong tool for the job. You wouldn't use a wrench to hammer a nail, right? Always check. Does your data's relationship form a straight line, or does it curve? Take a close look at your scatter plots and graphs. If it's straight, you're good to go. You can confidently use linear methods and trust your results. If not, you'll need a different approach. There are plenty of tools for non-linear data, but you have to know when to use them. This simple check can save you from misleading results. Don't skip it. Checking for linearity is a small step that makes a huge difference in your analysis. How do you check for linearity? Make a scatter plot. It's one of the simplest yet most effective ways to visualize your data. Plot one variable on the x-axis, the other on the y-axis. This helps you see how the two variables interact with each other. Each dot represents a data point, like a student's study time and their exam score. The more data points you have, the clearer the picture. Look for a general straight line pattern in the cloud of dots. This indicates a linear relationship. It doesn't have to be perfect, just a clear trend. Even a rough line can tell you a lot about your data. Most software can add a trend line to help you see the pattern. This can be especially useful for large data sets. If the dots cluster around the line, you have a linear relationship. This means one variable can predict the other. If they form a curve, like a smile or frown, that's a curvilinear relationship. This suggests a more complex interaction. For example, a little anxiety might help performance, but too much hurts it, forming an upside-down U. This is a classic example of a curvilinear relationship. If you see a curve, a standard linear test isn't the right tool. You might need more advanced statistical methods. Visual checks are quick and powerful. They can often reveal patterns that numbers alone might miss. Don't rely on numbers alone. Let your eyes guide you. Visual inspection can be a crucial first step in data analysis. A scatterplot can reveal the true shape of your data story. It's a powerful tool for understanding relationships and trends. What if your scatter plot shows a curve instead of a line? Don't panic. This is common and not a failure. The worst thing you can do is ignore it and run a linear test anyway. Instead, use a test designed for curves, like polynomial regression, or try transforming your data using a logarithm or square root to see if it straightens out. After transforming, check the scatterplot again. If it looks linear, you can use a standard linear test. If not, stick with a curvilinear analysis. The key is to be honest about what your data is telling you. Sometimes a curvy relationship is more interesting and accurate than forcing a straight line. Embrace the real story your data tells. Use the right tool for the shape you see. That's how you get results you can trust.